Welcome to the Deep Dive. Today, we're looking at a completely bizarre reality in modern construction for our Scaling Legends audience. I mean, imagine this. Down in the dirt, a contractor can now deploy a fully autonomous humanoid robot to walk a job site.
Right, yeah, they can climb scaffolding and inspect progress with, millimeter accuracy.
Exactly. It's pure science fiction happening right now. But at the exact same time, that multi-billion-dollar project might be completely paralyzed.
Just sitting as an empty dirt lot for 2 years.
Yeah, simply because a local suburban neighborhood doesn't want a power substation in their backyard.
It is a remarkable and frankly kind of a jarring juxtaposition. We're seeing incredible hyper-accelerated technology on the actual job site colliding head-on with these massive, immovable, macro-level bottlenecks.
And that is exactly our mission for today's deep dive. We are going through the day's critical construction market intelligence to figure out how these two extremes are impacting contractors.
We've got a lot of ground to cover.
We really do. We're going to look at why hyperscale data center mega projects are suddenly stalling out, how those humanoid robots are actually functioning in the mud, a deeply counterintuitive paradox regarding EPA deregulation, and how global geopolitical conflicts are squeezing local supply chains.
The overarching theme here for anyone running a construction business is that the landscape is shifting at just an unprecedented speed. I mean, contractors are being forced to completely recalibrate their risk management strategies while at the same time overhauling their technology.
You can't just focus on one or the other anymore, right?
No, exactly. The risk and the tech are fundamentally intertwined now.
Okay, let's unpack this. Let's start right at the top of the food chain with hyperscale data centers. For the last 5 years, securing a contract for a data center was basically a license to print money.
Oh, absolutely.
It felt like an unblocked, unstoppable expansion. But looking at the current pipeline, these projects are suddenly hitting a massive brick wall. And if the capital is there, what is actually stopping them? Like, is this a labor shortage issue?
It's actually the power grid, and to a slightly lesser extent, local zoning pushback. According to Smart Business Automator's market intelligence report, 22% of announced U.S. data center projects are now facing either severe zoning or grid constraints.
Wait, 22%?
Yeah, that is nearly a quarter of the domestic pipeline suddenly frozen.
There's a massive chunk of capital just sitting in limbo. But help me understand the mechanics here. We build massive commercial infrastructure all the time,
Yeah.
Why is the local power grid suddenly throwing his hands up?
Well, it comes down to the fundamental shift in what these buildings actually do. We aren't just building storage facilities for cloud data anymore.
Right.
We are building AI factories. The new generation of AI processors, they run incredibly hot and require immense amounts of electricity, not just to compute, but for the advanced liquid cooling systems required to keep them from melting down.
Oh, wow.
A single modern hyperscale facility might demand the exact same wattage as a mid-sized city.
Okay, so it's like trying to attach a fire hose to a garden hose. I mean, the local grids physically cannot handle the sheer volume of power these AI factories require.
Exactly. And the solution is to build massive new utility substations and run high-voltage transmission lines. But the supply chain for a high-voltage transformer right now has a 2 to 3 year backlog.
2 to 3 years. That's insane.
It is. And add to that the suburban and semi-rural public opposition. Local residents don't want the noise, the visual eyesore, or the massive construction disruption of a substation in their neighborhood.
So they show up at city council meetings and complain.
Right. They push back, zoning gets delayed, and the data center cannot break ground.
So this isn't just a temporary delay where a general contractor can just tell their crew to take a 6-month breather. If the local grid physically cannot support the load, the money has to go somewhere else.
Precisely. If we connect this to the bigger picture, this isn't just a temporary delay, it's a geographic shift. Because U.S. bottlenecks are worsening, international markets with better power infrastructure are capturing that hyperscaler capital.
Like where?
Look at Amazon's recent moves. They are dropping a massive $20 billion into data center infrastructure in Australia.
Wow.
That is a direct market signal. They are deploying capital where the power and the permitting are actually viable.
If I'm a domestic contractor watching $20 billion flee to Australia because of local gridlock, that's terrifying. But that dynamic sets up a really intense situation down on the ground.
How do you mean?
Well, if a contractor loses 12 months fighting a local utility for grid access, they have to buy that time back somewhere. And they're trying to buy it back on the dirt by compressing the actual construction schedule.
Yes, that is the exact pressure cooker driving the vertical adoption curve of job set technology right now.
Which brings us to the robots. A UK construction firm just achieved the first commercial production deployment of a humanoid robot for site inspections.
It's a huge milestone.
It really is. This piece of hardware physically navigates the site, captures visual and LiDAR data, which uses lasers to measure exact distances, document progress, and flag safety issues.
And Boston Dynamics, with their Atlas model, Figure 02, and Agility Robotics Digit, are all expected to push heavily into the construction space by 2026 or 2027.
But I have to play devil's advocate here. Are humanoid robots actually practical on a messy, muddy, chaotic job site? Or is this just an expensive PR stunt while a $500 drone could do the exact same thing?
What's fascinating here is that there's a very specific mechanical reason why the humanoid form factor matters. A drone is phenomenal for a topographical survey, or inspecting a roof.
Right.
But once the superstructure goes up, our job sites are fundamentally built for human bodies.
What do you mean by that?
Think about the physical environment of an active commercial build. You have temporary wooden stairs, ladders, tight corridors, scaffolding, and uneven floor plates with rebar sticking out.
Okay, yeah, that makes sense.
A drone cannot open a heavy fire door to inspect a stairwell. A wheeled rover, no matter how good its treads are, cannot climb a temporary ladder or step over an open trench.
So it has to have legs.
Exactly. A humanoid robot with articulated legs and arms is designed to navigate the exact same physical constraints and obstacles that a human worker does.
Okay. The environment is built to be traversed by humans, so the automated inspection tool needs to be shaped like a human. That makes perfect sense. But surely the end goal isn't just a very expensive robot walking around taking photos.
No, the hardware is just the collection mechanism. The true value is the automated loop it creates with the back office. While this robot is gathering millimeter-accurate LiDAR data in the field, artificial intelligence is revolutionizing the estimating and project management side.
So it feeds right into the software.
Right. For context, Consigli Construction CIO recently reported that AI in estimating is delivering their absolute biggest productivity gain. They are projecting a 30 to 40% productivity bump for their estimators within just 12 months.
A 30 to 40% increase in productivity is massive. How are they actually achieving that? Like, what is the AI doing that an estimator was doing manually?
It is about instant verification and adjustment. Connect the dots between the robot and the office. The robot walks the site at 2 a.m. It captures a perfectly accurate 3D scan of the newly installed HVAC ductwork.
Right.
It feeds that data instantly into the AI system. The AI compares that real-world scan against the BIM model, the Building Information Modeling System, which is essentially a master 3D digital blueprint.
Wow, so it catches errors automatically.
Exactly. The AI instantly flags if a duct is 6 inches off from the design and can automatically adjust material supply orders or alert the estimating team to a potential cost overrun. It is a complete closed-loop system.
If I'm a mid-sized contractor listening to this, I'm probably thinking, great, robots are walking the site, but how does that help me pour concrete faster? You can't just drop an AI estimating system and a humanoid robot onto a job site and expect the human crew to magically know how to operate alongside them.
That is the blind spot for so many technology startups entering construction. Knowledge and tools are only valuable when they are understood and applied by the people actually swinging the hammers and pouring the concrete.
Here's where it gets really interesting. NABTU, North America's building trades unions, and Microsoft are expanding a massive nationwide initiative to strengthen AI training across the skilled trades.
Yes, the Azure for Trades program.
Right. Their target is 300,000 apprentices and journey workers gaining AI fluency over the next 5 years. To me, this completely shatters the stereotype of the old-school trades worker with a paper blueprint and a pencil behind their ear.
It positions the skilled trades at the absolute bleeding edge of technology adoption, and it's a brilliant strategic move by the unions. Providing AI fluency to tradespeople ensures that the technology acts as a force multiplier for human expertise rather than a disruptive liability.
Give me a practical example of that. Like, what does AI fluency look like for a journeyman pipe fitter or a site superintendent?
Well, imagine a superintendent managing a complex hospital build. Instead of trudging back to the trailer to flip through a 10,000-page specification manual to see what grade of structural steel is required for a specific joint, they use voice-to-text on a ruggedized tablet.
Oh, that's smart.
They query an AI that has ingested the entire project spec book, and they get the exact answer, cited with the page number, in 3 seconds. Or, if the inspection robot gets stuck, a tradesperson with AI fluency knows how to troubleshoot its pathing logic rather than just treating it like a broken tool.
Right, because technology without human operational context is just expensive metal and code.
Exactly. It makes the human worker infinitely more valuable.
But while technology is drastically speeding up the physical building process, there's a very surprising paradox in the legal world right now. It threatens to drag construction right back down into the mud, and it has to do with environmental regulations.
The regulatory landscape is presenting a very tricky, deeply counterintuitive double-edged sword right now.
Let's talk about the recent EPA deregulation. On the surface, if you tell a contractor that federal environmental regulations are being rolled back, they're going to celebrate. Less red tape usually means faster builds and quicker permit approvals.
That's the assumption, yeah.
But looking at the situation, this deregulation is somehow creating immense, almost hidden litigation exposure. Wait, if deregulation removes the red tape, shouldn't that mean projects move faster? How is less federal oversight resulting in more delays?
This raises an important question. It is a fascinating paradox. Now, impartially speaking, just looking at the mechanics of it, what deregulation does is shift the enforcement mechanism from federal agencies directly into civil courts.
How does that actually play out on a project?
Well, under heavy federal regulation, a contractor submits their environmental plan to an agency, an inspector reviews it, approves it, and the contractor has a shield. They follow the federal rules.
Right, they have the stamp of approval.
Exactly. But with deregulation, those federal standards are loosened. This creates a vacuum that local environmental groups, non-governmental organizations, and angry local residents are filling through third-party lawsuits, often come in citizen suits.
So this EPA paradox is like taking down the speed limit signs on a highway, but letting the local residents hide spike strips on the road. You can drive faster, but a blowout is almost guaranteed.
That is a highly accurate analogy. You're no longer just dealing with a bureaucratic inspector who wants you to fill out a form. You are dealing with a highly motivated plaintiff's attorney representing a local group, and they will go to a federal judge to get a stop work injunction.
And the stakes are astronomical.
They are. Look at the recent Tudor Perini case. They were just ordered to pay $175 million over a Philadelphia hotel project. And the appeal cycle for that kind of litigation is estimated to drag on for 18 to 24 months.
$175 million hit, followed by 2 years of legal limbo. That would bankrupt almost anyone.
And we must remember that legal exposure isn't just limited to sweeping environmental law. Everyday standard contracts are becoming a massive vulnerability. According to Smart Business Automator's market intelligence report, a staggering 68% of smaller contractors are currently using outdated contract forms.
It's 68%. That's huge.
They are operating completely exposed to these new legal realities. Fortunately, we're seeing regional organizations like the Tri-Cities Builders Group actively broadening access to standard, updated mid-market contracts to help fix this. But the vulnerability remains widespread.
If I'm bidding on a project tomorrow that involves any sort of land clearing, what is the immediate actionable takeaway to protect my business from this civil litigation shift?
You have to price the risk into the bid. The immediate recommendation is to budget your legal reserves 8 to 12% higher on any projects that have water, air, or wetland exposure. You cannot assume the old legal budget will cover a modern litigious environment.
Okay, so domestic legal battles are forcing contractors to pad their budgets, local power grids are freezing data center projects, and if that wasn't enough to force the industry to adapt, the global supply chain is throwing some incredibly heavy curveballs.
Oh, absolutely.
We are seeing a severe squeeze on specific physical materials.
The geopolitical landscape is having a very direct, undeniable impact on local procurement. Global conflicts do not just stay on the news, they show up on your material invoices.
Let's look at the Iran war. This conflict is severely straining global construction material supplies. We are looking at specific, acute shortages of steel billet, specialty alloys, and electrical components. And this is compounding a recent massive spike in the cost of Middle East float glass. Why float glass specifically? What does a conflict in the Middle East have to do with the windows on a high-rise in Chicago?
Well, it comes down to the manufacturing process and regional energy hubs. Float glass, which is the perfectly flat, clear glass used in modern commercial facades, requires massive, continuous gas furnaces to melt the sand and float it on a bed of molten tin.
Right.
It is an incredibly energy-intensive process. The Middle East has historically capitalized on its abundant, cheap energy to become a major global manufacturing hub for float glass. When regional conflicts erupt, It disrupts the shipping lanes, spikes regional energy prices, and immediately throttles the export of that glass.
Which means the lead time for your high-rise windows just tripled.
Exactly.
But here's the crazy part about the global dynamic right now. Despite these severe material constraints and war-driven supply shocks, international construction markets are absolutely booming. I mean, the numbers are staggering.
They really are.
The UK construction sector is up 170% over a 5-year period. Canada's market size is projected to reach $430.98 billion by 2034. Indonesia is projected at $226.1 billion.
It's a classic push-pull dynamic in global economics. You have severe supply constraints on one side of the globe and exploding infrastructure demand on the other.
Right.
Add to that the push for new methodologies. Saint-Gobain just published a massive sustainable construction framework focusing heavily on low-carbon concrete and adaptive reuse of existing structures. That framework is expected to heavily accelerate adoption of these sustainable practices here in the U.S. as contractors look for ways to bypass traditional supply chains.
So what does this all mean? How does a domestic U.S. contractor actually handle this? You have the squeeze of overseas material shortages, making my local builds more expensive, while at the same time, there is this massive temptation of booming international markets like Canada.
It's a tough spot to be in.
It feels like you're getting punished for staying local with gridlock and legal fees, but expanding internationally is incredibly risky. How do you balance that?
It requires a highly strategic geographic hedging approach. You cannot just rely on your local 50-mile radius anymore. For a U.S. contractor, if your firm has any NAFTA, USMCA, or Asian regional experience, you should be actively positioning to capture some of that Canadian or Indonesian boom.
Oh, I see. You use the international growth to offset the domestic pain.
Exactly. You use those high-growth international markets as a hedge against the domestic material volatility and the U.S. data center gridlock we talked about earlier. Diversifying your geographic footprint is the most effective way to balance out regional supply chain shocks.
Yeah. We have covered a massive amount of ground today, from the invisible walls stopping billions in capital to the physical robots walking the site. Let's distill the core takeaways from all this intelligence so our audience can actually apply it to their business this week.
That's good.
First, audit your data center pipeline right now. Look closely for local public opposition on grid access risks before you commit resources.
So definitely.
Second, start piloting AI training for your estimating teams immediately. A 30 to 40% productivity gain is too large to ignore while your competitors adopt it. Third, update your legal reserve budgets by 8 to 12% on any projects impacted by EPA deregulation or involving wetlands, water, or air quality.
And to end on a note of bidding stability amidst all this volatility, Nevada construction wages are currently holding very consistent. If you are operating in that specific region, that wage stability allows for highly predictable, accurate bidding in the near term.
That is a very welcome sliver of predictability.
But as we step back and look at all these moving parts, I want to leave you with a lingering thought to consider. We are watching humanoid robots perfectly document site inspections. We are watching AI instantly calculate estimates with flawless mathematical accuracy.
Right.
As these technologies perfect the cold science of construction, what happens to the value of human intuition? Will the gut feeling of a seasoned superintendent, that innate, unquantifiable ability to walk a site, smell the air, and just feel that a schedule is slipping a week before the data actually shows it, will that become an obsolete trait?
Wow.
Or will that human intuition become the single most expensive, sought-after luxury premium in the industry?
That is an incredibly fascinating question to chew on. The technological X-ray machine of construction is getting sharper every day, but the human element is still what holds the entire building up.
Listen, if you know a contractor who is dealing with stalled projects and rising legal risks, send them this deep dive. It can help them recalibrate their legal reserves and estimating tech before the next bid. Hit follow on whatever app you're listening on so you don't miss tomorrow's intel. And be sure to visit smartbusinessautomator.com. We will catch you next time.